Hello, and welcome to the second video in the Getting Started with Garden video series. In the first video, we looked at the how and why of Garden, and you'll find links in the description. In this one, we're going to go through the entire process of adding Garden to an existing project using a 3-tier web app as our example. Now, we're adding Garden to an existing project, which means we're at the next steps page of the Getting Started section of our documentation after all of the quick start stuff. This page explains high level the steps involved in adding Garden to an existing project, so we'll mostly just follow along. Specifically, we'll create a project, pick our plugins, and then add our actions. To create a Garden project, you need to add a garden.yaml configuration file at the root of your project. So I'm just going to go ahead and copy this snippet here and then switch over to my terminal where I have the example project clone. So let's start by looking around a little bit. You can see that it's a 3-tier web application with API and web components, and we'll add the database later, and we have our Docker files and the manifests. Now, the first thing I'll do is add the Garden configuration file. I'm just going to call it project.garden.yaml. You can also just call it garden.yaml, and then I'll paste in the snippet that we just copied. So this is the basics of a Garden project configuration. I'll go ahead and change the name from my project to 3-tier since we're building a 3-tier web application. And with this, I can already start using Garden. I'm going to start by logging into the web dashboard, and then I'll go ahead and start the interactive dev console by running the Garden dev command. Now, this gives me access to the web dashboard, so I'm going to go ahead and follow the link here. And that takes me to the live page of the Garden web dashboard. I'm going to switch over to the graph view. But as you can see, there's not much here yet because we haven't added any actions yet. So let's go ahead and do that now. So I'm going to start with the exec plugin, which is actually built in, so I don't need to do anything here. I can get straight to adding my actions. Remember that we're building a 3-tier web application with web and API components that need to be built, deployed, and tested, and a database component that needs to be deployed and seeded. So let's go ahead and start with the action for deploying the database. Now, every Garden action has a kind, a name, and a type. The kind is one of build, deploy, test, or run, and well, therefore building, deploying, and testing your system, and the run action is for one-off jobs such as database migration, auth scripts, and things of that nature. We also have a type which determines how the action is executed. So here we're using the most basic action type, the exec type, which just executes a script on the host, in this case my laptop, and we're just telling it to echo out the string deploying DB. So what we're doing is using the exec action to create kind of a blueprint of our project. All the things need to happen to go from 0 to a running and tested system. You can think of them as placeholders for now, and we'll gradually replace them one by one with the real thing. Next, I'll go ahead and add the action for seeding the database. That one has kind run, and you can see that again, we're just echoing out a string. Note that this one also has a dependency on the database being deployed. Now, if I switch over to the graph, I can see the actions and the dependency relation between them. Now, to run actions, you use the Garden CLI. You can run them with the CLI directly from within the dev console or via the dashboard. Every Garden action has a corresponding command, so you have commands for building and deploying actions, so on and so forth. Here, I'm going to run it from within the dev console. So I can type in run, and you can see that it auto-completes for me the name of the command and the name of the action, and when I hit enter, it's going to run the action. So you'll see that it logs out that it's deploying the DB and seeding the DB. I can see the logs here in my dev console and similarly in the dashboard as well. Now I'll go ahead and add in the rest of my actions, and you'll see they look similar to the actions that we already added. We have build actions for building the web and API components, and similarly deploy actions. You'll notice, for instance, that the deploy actions, say for the web component, depend on the web being built, but also on the API being deployed. We also have a test action for end-to-end or integration testing our system that depends on the web part being up and running, so it sits at the end of the graph. And as I hit save here, you'll notice that the graph updates in the background. So here I basically have a blueprint of all the things that need to happen to go from 0 to a running system. The build actions and the deploy actions and the tests. So I can, for instance, try running the test from the dashboard view. And you see that Garden in dependency order executes the actions and eventually runs my quote-unquote test. Obviously, we're just using these as placeholders for now. And similarly, in the log view, I can again see how Garden is executing the actions, building the API, the web part, so on and so forth. Now, this is great for getting an overview of how the system fits together and account for the dependencies, but obviously not very useful. So the next step will be to replace these placeholders with the real thing, one action at a time. So now it's time to add our Kubernetes plugin. The way you add plugins is you list them under the providers field in the project level configuration. Here we're adding the ephemeral Kubernetes plugin, which means Garden will basically spin up a cluster for us on demand and manage everything for us. Garden also has plugins for local Kubernetes and for using your own remote Kubernetes environment. And now it's time to replace our placeholder actions with the real thing. While you weren't looking, I went ahead and removed the actions we added to the project level configuration and put them in their own files. So you can see here that the API and web directories, as well as the DB directory we just added, all have a garden.yaml file. And these files now include the actions that we added in the beginning. Okay, we want to deploy an actual database. So what are our options? Coming back to our documentation real quick, you see there's a section called Kubernetes plugins, and there we can see what actions are available to us. We can deploy it as a container, we can use Kubernetes manifests, or we can use Helm charts. We're going to go for Helm charts this time around, and you can see here on documentation more or less how that's set up. Coming back to my configuration, I'll change the type from exec to Helm and change the spec. So the spec field is always going to be specific to the action type that we're using. Now I'll go ahead and copy in the spec for deploying a Helm chart where we're using the Postgres Helm chart. So you can see it's fairly straightforward. We're telling Garden what chart to use, as well as overriding a handful of values. Let's save these changes. And now, if I switch back to the graph view, you'll see that whereas before this here action had type exec, now it's type Helm. And I can actually click this, I can run the action, and what's going to happen is Garden is going to actually deploy a Postgres database via Helm, as opposed to just echoing out a string. If I look at the logs here, you can see that it's actually behind the scenes doing a Helm install for this particular chart. While that continues running, we can switch back to our config and add the action for seeding the database. Again, we have a few options here. This time around, I'm going to go for the container type, which essentially means that Garden's going to spin up a pod in my Kubernetes cluster using the container image that I specify and run a given command. So let's change this from type exec to container, and then update the spec as before. And you can see all I'm doing is telling Garden what container image to use and what command to run. So now if I switch back to the graph view, you can see that it has type container, and I can click here to run the action and see the database. And what's going to happen is Garden's going to check the status of the Helm deployment. It sees that it's up to date, and it will then proceed to actually run the command that I specify and see the actual database. Alright, now we're getting to the interesting part. We're actually building and deploying our own source code as opposed to pulling in off-the-shelf Helm charts like we did before. So, starting with the API build, that one's going to be simple. We're going to change the type from exec to container, and we don't need any configuration beyond that. Remember that garden.yaml file is co-located with the source code, so Garden will know where to look for a Docker file and the rest of the build context. So now I can go ahead and run the build. I'm going to run it from the interactive dev console this time around. I can type build to run all my builds, or just build API to build the API specifically. What's going to happen is the Garden is actually going to build my container image remotely in the cluster. You can configure this via different build modes, but this is great because it allows me to share build caches with my team, and I don't even have Docker running on my laptop. I'm going to switch back to the graph view one more time. First of all, I can see the logs from the build here, but also what I want to show you is that if I run this again, Garden's going to check the status of the build, and it's going to find that the code at this exact version has already been built. Now this is great when you're collaborating with a team. Imagine a team of 5 or 10 developers. Once that first developer builds a given action at a given version, all the others can benefit from reusing that build cache. So for large projects and large teams, this can mean massive time savings. If I were to change the actual source code and then click build or build from my terminal, it will of course rebuild the image. Next up is the action for deploying the API service. As always, I have a few options here. I could use Helm again if I had Helm charts for this particular action. I can also use the container type if I don't have any Helm charts or Kubernetes manifests at all, and then Garden will generate those for me. In this specific case, I actually have the manifests at hand. I highly encourage you to use either Helm or Kubernetes, because that's just a lot more flexible than the Garden container type, and allows you to configure things at a much more granular level using the underlying tools. So we'll change this from type exec to type Kubernetes. Of course, the dependencies stay the same, and then we'll add the proper spec. And that is relatively simple for now. All we're doing is telling Garden where to go look for the manifest. So Garden knows it's type Kubernetes, it knows where the manifests are, and it can basically figure out the rest. I highly recommend this pattern of first trying to model the entire system, then replacing one action at a time and testing them as you go along. So we can just do deploy API. And now what's going to happen, predictably, is that Garden is going to first check if it's already built. It will find that it is built, and it'll go ahead and deploy it using the Kubernetes manifest that I've specified. Now, at this point, you might be wondering, how does Garden know what container image to deploy? Remember that we're building the container here, and Garden attaches a version to the container image that we built. we need to somehow reference the output from this build action when we apply the manifest. Every Garden action defines a set of outputs that you can reference in other actions. As always, there are a few different options. If we were using the Helm type, for instance, we could just set this in the values field, but we're using the Kubernetes action, and the recommended approach here is to use the patch resources field. So all we're doing here is we're telling Garden, look for a deployment that has the name API and apply this patch to the deployment. That is, find the container that has the name API, this is all defined in the manifest, and set the image to this here value. So these are Garden template strings. And what we're doing here is we're looking for a build action called API. We're referencing its outputs and specifically the deployment image ID. Documentation, you'll find all the outputs for all the different action types. This is how we can be sure that we're deploying the correct version of our source code. Now, there's one more piece of config I want to add here, and that's the default target. Your Kubernetes manifest can contain a lot of things, your ingresses, services, even multiple deployments for that matter. So this tells Garden where to go look when running certain utility commands, such as the logs command and the exa command, which I'll demo a little bit later. Now, last but not least, the web component, the final part of our system. The configuration for that one is going to be more or less exactly the same as for the API component, so I'm not really going to dwell on it. If you're thinking to yourself that feels a bit repetitive, no worries, we got you covered. You can define reusable config templates that do away with all the boilerplate, and this is great for platform teams that want to author or vendor certain Garden actions that other teams can reuse. They can be stored in any repo, and Garden knows how to pull them into the project where you want to use them. So we're going to hop straight to the test, our end-to-end test, or this could also be an integration test or API test. I'm using the term end-to-end here. That's still of type exec, so we want to change that into the real thing. Similar to what we did for the database migration, we want to use type container. So we'll just change this here to type container. And then we need to specify what image to use. And again, we want to reference the output from the actual web build. And that is going to look something like this. Again, we're telling Garden what image to use. It's the output from the web build and what command to run. Now, in the graph view, I can, of course, run the action as before and view the logs as I do that. And ideally, our test passes. There you go. Now, what's interesting here is, remember earlier when I showed you how Garden is able to reuse build caches? The same goes for tests. So if I go ahead and run this test again, the Garden will just tell me that it has already passed. So again, for large projects with a lot of tests, this can mean a lot of time savings, in particular in CI, where Garden is also able to leverage the test caches from runs from other CI runs, or for that matter, while you're developing. Speaking of CI and switching gears a little bit, so far we've been running Garden commands via the interactive dev console or from the dashboard, but we can obviously also just run them with the Garden CLI directly, which is what you would do in CI. So you can imagine a job in your CI pipeline that, for instance, runs the Garden test command or the Garden deploy command, and it looks something like this. Whereas before you had presumably quite a lot of YAML in your CI configuration, you can really just boil or reduce that down to single Garden commands, because if you think about it, what we've been doing so far is we've been describing the entire system. We've created a blueprint of how you can build your system, deploy your system, and test your system. And in a follow-up video, we'll look into how we can do that across multiple environments. You'll see, again, Garden caching mechanism at work. A lot of these things are already built and already deployed. The command is going to be super fast. Also, it prints the links to the actual application that we're working on. We haven't even taken a look at that, so let's do that real quick. It's a simple voting application where we can vote between flowers and trees. Alright, so we've covered a lot of ground so far, but there's one final piece of config I want to show you before we wrap up. That is the sync config that we can add to our deploy actions. Now, when you're using Garden for development, you don't really want to rebuild and redeploy on every code change. So with syncing, Garden will hot reload or live stream the changes from your laptop to the running container in your Kubernetes cluster. The way you specify syncs is that you list the paths that you want to sync. Here we're syncing the source path on my local host or on my laptop to this here path in the container. We're excluding the node modules, and we're overriding the container such that it starts up with the npm run dev command. Normally it would start up with something like npm run serve. Here we're using the dev command when we're in sync mode. To deploy your project in sync mode, you can either run the Garden deploy --sync command or simply run it from within the dev console. Now what's going to happen is that Garden's going to redeploy my services if needed and make sure that they have syncing enabled and that they start up with the correct command. Coming back to the dashboard, I can see that I have 2 out of 2 syncs active. I can also validate that it works by streaming logs from my API and web services for which I have configured the sync, and switching over to my IDE. Let's say I pop open the API and make a few changes. So here we're, for instance, printing the string starting API. When we start up the API service, just going to add 3 dots to that, hit save, and you'll see that it logs the changes here. Basically, the remote service is updating immediately as I make these changes. We can also look at the web part of the system. So here is the link to our web part, which now has sync mode enabled. Remember the voting app from before? You'll see that it has red and green colors. So as a final example, let's hop over to the code in the web part of the system that is responsible for rendering these colors and change them real quick. And you should see that as I hit save, the browser updates right away. So this is super fast, even though I'm streaming the changes from a laptop to a remote Kubernetes cluster. And that is it for now. In follow-up videos, we'll see how we can use Garden to add even more environments and use it with our own Kubernetes clusters. We'll also see how we can use the Terraform and Pulumi plugins to fully automate the process of building, deploying, and testing our system across all stages of software delivery. Thank you so much for watching, and I'll see you in the next one.